Hi, welcome to everyone's favourite segment, Mailbag Monday. Yes, it's Mailbag Monday is back because I put a poll on the EEVblog forum and I asked would people like to see to bring back the weekly Mailbag Monday segment as I used to have it, and the majority of people said yeah, I'd love to see it. But unfortunately the only way I can really do that is my mailbags have become a bit of an epic. Like I opened 6, 7, 8 packages, something like that. They're 40+ minute videos, so I thought I'd try to go back to the regular Mailbag Monday segment where I release it every Monday-ish every week, depending on time zone that you're in. There can be more than a 24 hours time difference between, you know, New Zealand and the arse end of the planet. So the plan is every Monday again, but I'll only do 2 packages every time, just to keep the video length down. So anyway, let me know what you think about this new format down below in the comments or over on the EEVblog forum. So let's get into it. I've got the knife. That's not a knife. That's a knife. Let's go. Or I might actually have more than 2 per episode. It depends. What I'm going to do is just like shoot a bunch of them and then just, I'll still show all mailbags eventually, but I'll open a bunch of them and then actually decide, sort of like pick and choose some to include in each particular episode. But rest assured, I still will eventually show them all. Anyway, we got one from WIHA. But the idea is like to keep it down to like 15 minutes or something like that. Let's try it. WIHA make awesome tools. So we could have tool porn. Yeah, so all right. Oh yeah, no, that had a weird foldy thing in it. Whatever. Anyway, WIHA, oh look at this. Comes shrink wrap for our protection. What do we got? It's the SpeedE. Foo! It's a screwdriver, but it's a special screwdriver. Let's check it out. Oh, hang on. Oh, yeah. Oh, look at this baby. Oh, come out of there. Oh, attachable chips. Oh, geez, look at that. Look at the cardboard in that. Wow, that's pretty jazzy, isn't it? Wow, fancy pantsy. Okay, they just mold. It's like, you know, like a laser cut. I'm sure it's punched. Yeah, it looks punched. Anyway, geez, this is all fancy pantsy. Look at all the manuals and stuff. I don't know what that means. Some customer club thing. Look, oh, look at this. Fancy case. So we got a jazzy case with it. Oh, look at that. Looks like we've got an 18650 charger. Terrific. And looks like, oh, look at this. We've got a whole bunch of tips. How do you, tip porn. Shame they're like all in like a thing like that and they're not like individually done like that. But anyway, the whole idea is that this is apparently, if you haven't guessed it already, an electric screwdriver. So we've got, single 18650, the 18650 in the bottom, and Bob's your uncle. Oh, yeah, we've got a light. Schmick. Oh, made in Germany. Let's check it out. Oops, I almost missed the battery here thing. There was a battery in the box, but there's also a battery in here as well. Keep power, produced for WIHA. The IC made in Japan, but assembled in China. Yeah. Ooh, extensive quick start guide. 1, insert battery. 2, insert screwdriver tip. 3, twist the thing to make it go. Fantastic. 2 times faster than what? Electronic rotation? I'd like to think so. It's a battery-powered screwdriver. 0.4 Newton meters of a torque. Does it have torque protection? Like, I don't think it's adjustable torque, but maybe it has a limit. And fix with feel-in. It's got proper type approval for high voltage. Awesome. And it's recommended by doctors, apparently, who have to operate on you on high voltage. Oh, there you go, twice as fast thanks to a 3-step process. Protect your material. Electric fastening with protective function to prevent damage to materials. Max 0.4 Newton meters. Increase your control. Fixing by hand with full sensitivity. You got to have sensitivity on your grip, that's for sure. Increases your efficiency. Electronic ratchet for rapid fastening without any re-gripping. Well, you don't have to re-grip your shaft. Bugger that. Ooh, compatible with the slim bit system. Maximum freedom of choice. Open system with rechargeable standard battery. Offers you full protection. Tested at 10,000 volts AC and approved for 1,000 volts. Nice. Protects your health. Recommended by the German doctors and therapists of the German Association for Healthier Backs. You can't argue with that. Is that maybe some chiropractic woo-woo? So there you go, there's a 3-step process. You got the regular screwdriver mode, then of course 0.4 Newton meters torquing, and then you screw it by hand up to 8 Newton meters. Otherwise, what, it snaps the shaft? I don't know. There's the specs for those playing along at home. 127 grams, IP44 protection. Charging time, 75 minutes. Well, that depends on where you charge the battery. I don't think it's chargeable inside, is it? Anyway, they don't tell you how long it, typically lasts. How many, typical screws do you get? And you got various lighting modes, low battery, indicator, stuff like that. So, maintenance cleaning, that's it. Alright, let's check this bad boy out. Don't know about the box, though. I think it's a bit overkill, you know. Anyway, ooh, I just accidentally touch that? Light comes on. Anyway, it looks and feels very schmick. Made in Germany, of course. There you go. There's a look at it. 0 to 8 Newton meters of torque. Rated. Of course, it doesn't go up to that in the electric mode. Yeah. Battery charger looks very nice. 18650. Of course, it's not just useful for this. You can use it for anything. So that'll replace a little Krusty Burger one that I've got. So that's terrific. Is that some sort of, that looks like an extender, is it? Because that's not going to, I don't think that shoves into there, does it? Oh yeah, no, there we go. Oh, that was satisfying. Hang on, let me do that again. Oh, beautiful. Just got a charger with one of those weird ass plugs on it. Absolutely useless as tits on a bull here, but here we go. Here's what we want to see. Look at all the tips that comes with it. Oh, got some posies in there. Regular Phillips. Very nice. There's a bit of play in that. Look at that. Bit of wobble in that. I would have liked to have seen that. It just goes in a decent. The problem is, you can't see the orientation of how it goes in. Because it's as far as you can tell, that is just like a circular thing, but of course it's not. It's a hex thing, and, well, bit of play in that. It didn't do it the first time. Why? Is that I assume it doesn't detect anything when you plug it and unplug it. Okay, if I put that in, let me do it. Oh no, there we go. It just seems to shut off. It's definitely not a torque-based ratchet thing. I'm not of it. It just cuts out easily. But I've tried to go the other way. It's a harder time. I'm having a harder time stopping that. It doesn't slip at the end of the. Okay, well, I'm guessing that kind of makes sense in that it just stops electronically when it gets to that point. Oh, I've got no way to measure the torque on this thing, really. But, yeah, I guess it stops electronically, and then you're free to go like that. Because if it ratcheted, I guess, if it, slipped, like a regular torque drill, for example, then you wouldn't be able to just, as soon as it finished electronically going like that, then you wouldn't be able to just turn it like that, because you'd have to change modes, and it would, to fix it in so that you could go like that. So that's purposely designed, so that's fine. All right, well, let's see if we can open something here. I've got my RF SigGen. Fail. Can't do it. Sure enough, I can go like that by hand. There we go. Once it didn't have enough torque to unscrew that on the back. Oh, let's try it again. No, I've got to get it going before it'll do that. It's not particularly fast. Look down in there, you can see that there's like a pogo pin down in the bottom there. That's not too shabby. Don't mind that at all. And they've got metal ring all the way around here. And that's the got O-ring seal on the back. Not too bad at all. And that looks like quite a reasonable system. It should take a reasonable amount of abuse, I would think. Feels really good quality plastic and everything else, so no worries there, as you'd expect from WIHA. So, yeah, it's nice and solid. Can we bend that? I'm trying to, but maybe I could, like if I put a lot of tension on that, I could maybe break it, but yeah, it seems pretty robust. Don't mind it. Oh, it just dawned on me, these are 18500s, not 18650. So I don't have anything or know of anything else that uses 18500s. That's a bit of a mistake. I mean, surely they could have made it a little bit longer to accommodate the standard size 18650s. I think that's like, because it doesn't, right, it could have been longer. Well, I don't know, I've got a smallish hand, I guess, and it's kind of like, almost seems a bit short, maybe. They could have made it a bit longer and it still would have been fine. So, yeah, that's a bit of a fail. 18500s? Give me a break. Because there's an 18650 with protection and it's not hugely longer than the 18500. So, come on. Well, let's give it a go on this. As I said, it doesn't start like that. You've got to, like, give it a start. And then it's probably not the world's fastest. Oh yeah, there we go. I give it a little, just a little turn like that. Yeah, that's not bad. That's working all right. No worries. Yeah, just got to give it a little slightest twist as a start. So probably would have liked to have seen it maybe a bit faster. Maybe have dual speed or something like that so you could select it. But yeah. That's all right. Okay, let's now whack them back in. And the form factor with the, like the usability with that is not too bad. Seems to work. So they thought about the implementation of that. So let's put it back in now. There you go, and it stops. And you got it, yeah, it's not too bad. Just give it like a little quarter turn at the end, like that. And yeah, it's not too bad. There's a bit of slip in the thing as I go like that, then there's a bit of slip in the motor before it actually starts to turn like that. So slight downside there, but not that bad. So that's not too shabby. It's a shame it just doesn't have like a proper shame it's not a proper torque thing, but I guess that's not its idea. If you want that, you know, you got to buy a proper Panasonic cordless driver, something like that. One of those professional ones. If you really want that sort of business, but it seems to work all right. So it's not bad. Seems really good build quality. I think it'll last a long time. I don't think you'd have too many issues with it. The battery life remains up in the air. I don't know what the battery life with this thing is. Shame about the 18500 instead of the 18650. But the killer with this is the price. This is 500 Aussie bucks. This is more than twice the price of the Panasonic Professional cordless screwdriver with the torque, you know, with the adjustable torque ratchet system and everything else. Granted, it's a different class of thing. This is like, you know, 1000 volts insulated and stuff like that, but I don't know why you'd necessarily need, you know, 1000 volt isolated screwdriver opening hundreds of screws. Like, I okay, you know, it's nice, but I don't know why that'd be a requirement. If you're after a professional screwdriver, I think the Panasonic's probably a better option. Granted, this thing has your traditional form factor like this, so the ergonomics of it are very, very good. So I guess you can't compare them. They are different tools to a regular chuck-based, ratchet, torquing cordless screwdriver, and the Panasonic's a totally different form factor. So I don't know if this is unique. I don't know of any others that have the same similar sort of form factor. So from form factor point of view, as a regular, and you can just automatically use it as a regular screwdriver like that, no problems whatsoever, and then just go like that. So ergonomically, it is very good and works very well, but yeah, Jesus, pricey, 500 Aussie bucks, unbelievable. So it does seem to have limited functionality too, in terms of not being able to set the torque setting, and also the speed of the thing. It's slightly on the slow side, but it's still very useful. If you're opening a product with, you know, dozens and dozens of screws like RF cans and stuff like that, then yeah, it's really going to save time, no doubt. But we probably would have liked to have seen, you know, like maybe a switch on it, just multiple speeds or something perhaps. And really it doesn't, or even just a velocity control kind of thing, like you turn it a bit harder and it goes faster, but that's not the case here. Doesn't matter how much you do that, it's just the one speed. Thank you very much, Andrew Haas from New York. Hi to all my viewers in New York, and well, I know what's in here. You're probably not going to pick it by the size of this thing, but anyway, well, it's one of these little USB doodads. Let's have a look. It's an open everything hardware, firmware, software, 4-channel oscilloscope from a recent successful crowd supply campaign. It's the HaasoScope. Bandwidth is 60 meg. Anyway, 60 meg analog bandwidth. Sampling rate is up to 250 meg sample per second. That's good enough. All for $115 US. You can plug them together to instantly add more channels. There's plenty of other nifty features. Okay, that's pretty groovy. But it's all about the front end. I can see that the front end is got a couple of trimmer pots on there and stuff like that. So it certainly won't match a regular scope in terms of like input functionality on the like ranges and everything on the front end. But I presume it's only an 8-bit scope. But anyway, let's check it out. And it's a 4-channel, 60 meg analog bandwidth, 250 meg sample per second, cascadable, hence the connectors on the side. You can join them to get more channels. Digital USB, of course, digital storage oscilloscope. Andy writes, I know you're not a huge fan of USB oscilloscopes, but I'm hoping this one will change your mind. It's an open everything hardware, software, firmware, software 4-channel oscilloscope from a recent successful crowd supply campaign. And it's got decent bandwidth and sample rate for 115 Yankee bucks. And, well, let's take a look at it, see if it's any good. So the problem is you can actually get cheaper USB digital storage oscilloscopes from the likes of O1 and Handtech that are complete in a case for less cost than this. So yeah, it'd want to add something special, but hey, they're typically only 2 channels. This one's 4-channel. It doesn't have, usually doesn't have the 60 meg analog bandwidth, doesn't have the higher sample rate, 250 meg samples per second, not cascadable like this one is. This one's got a little screen. From what I've seen, that's it might be optional because the ones I've seen online don't actually have that. So it's got to offer like, better performance or better software or better functionality or something like that, as opposed to a cheaper, more polished product from at least, not a huge brand name, but at least known brand names like O1 and Handtech. Now let's take a look at the front end. We've got the 4 BNC connectors, 4 channels with switchable 50 ohm and 1 meg termination, and that's fine except for our first problem. Let's just use some O1 probes. Houston, we have a problem. How about these PostScope branded ones? Nope. Keysight probes? Nope. I did finally find one that actually fitted, these GW Instec ones. Just. But even then, they're slightly splaying out, so I think you'd have a hard time getting in the third or the fourth one. So basically, just consider this unusable with any type of ×10 probe, and that's ridiculous considering the otherwise quite good 60 megahertz analog bandwidth supposedly, and that's a fail. But it works fine with standard B and C cables, but yeah, that's pretty much all you're going to be able to use it with, I think. So really, right there, it's claimed to be like a proper oscilloscope. No, sorry, it's not. You've got to have the switchable, the ×10 probe capability, the lower capacitance to get the bandwidth required, and also considering the lack of input voltage ranges like this compared to a normal oscilloscope, you need the ×10 probe to get the higher voltages as well. So yeah, nope. And herein lies the next problem, which I was hoping wouldn't be the case, but it often is with these type of projects, is that it's all on GitHub. And I'll get to that in a second. Let's have a look at the original crowd supply. Raised $18,000 of $10,000 goal. Excellent. Well done. MicMakes had, it comes to, I reckon it's pretty decent DSO for the price. First open source, open hardware, flexible, small sheet data acquisition board. I think we're going to find that this is more of a data acquisition board than an oscilloscope. You already can't plug oscilloscope leads in it, so already I don't class it as an oscilloscope. Who needs it and why? High-speed circuits, action learn, FPGA programming, data transmission protocols, all that sort of thing, which is great. It's probably a decent platform for that. Now, the problem is, yeah, you can reprogram the firmware, but you can only do it over the JTAG interface, and you've got to use the Altera Max software. So it's like right there, that's not great either. It's terrific. Maybe if you're using it as an FPGA development tool and you want to hack around with it and customize it and all that sort of stuff. Anyway, we've got 2 gains per channel, plus minus 5 volts and 500 millivolt ranges. See, that's not enough. That's why you need the ×10 probes to get greater than your 5 volt range, and also the bandwidth required as well. It's got spare digital I/O lines and 9 additional analog 1 meg sample per second 12-bit ADCs. That's pretty cool. Okay, so it's really quite flexible in terms of single header input ADCs at 12 bits, or the B and C ones for 8. I think it's probably arse about. They probably should have dedicated this to a data acquisition, a more geared it towards a data acquisition, a 4-channel data acquisition thing with the 12-bit 1 meg sample per second B and C inputs perhaps, but you know. So here they are comparing it to the Rigol and the Picoscopes and the O1s and OpenScopes, the Smart, and right off the bat, it's not, yeah, its price per bandwidth is probably, and sample rate is probably going to be pretty decent, but here's some screenshots of what we can expect. But let's go back over to the GitHub here, and here's my problem. I'm not a user of GitHub. I kind of can maybe download some stuff, but it's a pain in the ass. Look, I was looking for the front end of this thing. Oh, where's the schematic? Okay, I go into the Eagle. See, the thing is, it doesn't tell me which one is the schematic. I had to go through here. Of course, we've got the Eagle schematic and stuff like that. Don't have Eagle installed. It's actually the PDF document here, which we can actually download and open up. But there we go. We finally got our schematic. Geez, look, they got lines going through the FPGA. That's a bit how you doing. What's going on? I'm sorry, but what there? We have a serious. Do we have a formatting problem, or is that how the schematic was? That's a pretty horrible looking schematic, I must say. Wow, what's gone wrong there? That's got to be a formatting issue to PDF. Anyway, that's terrible. That needs to be completely tidied up. That makes absolutely no sense whatsoever. There's no flow to that. There's no traditional left-right flow for your signal inputs or anything. This is horrible. Here's our, looks like this is our B and C here, is it? Wow. This is not good. This is not good. Oh, wow. Okay, so there, They're our two ranges, okay? So that switches from, okay, that switches our range, does it? And then it goes into a max 4416, which is a high bandwidth op amp. And oh wow, that is terrible. So I thought this must be a problem with like the PDF output formatting or something like that, because I've seen things happen like that before. So I actually installed the latest version of Eagle and I loaded in the Eagle file from the GitHub, and nope, that's exactly what it is. Wow, this is just shocking. Like, I've never seen a schematic. I don't think I've ever seen a schematic this bad before. I don't know what the deal is here. All the designators and everything all over the shop. And like if you go down here, sorry, I don't know how to pan on this stupid thing. You've got the wires going through the middle of the chips. This is just, it's just insanity, absolute insanity. And like, these are your B and C's up here. Like, they're, okay, kind of, right? What, like, and it's just these over here. What is this? Like, words cannot express how bad this, what is it? What? Words cannot express how bad this is, and I'm supposed to be impressed by this? Sorry. No. Now, herein lies the problem with open source hardware, right? This is supposed to be all open source hardware. Fantastic, okay? And so many hundreds of people have presumably already gotten their thing on their HaasoScope on crowd supply and everything like that. And presumably all this, they've all seen all the release material and all this sort of stuff. So there's at least many hundreds of people who have presumably seen this. And not one of them went, I can't make heads or tails of that schematic. That is just insane. I need to tidy that up. Not one single person has bothered to go in there and tidy this up and then resubmit it to the GitHub. You know, and this is supposed to be the advantage of open source hardware, because if I was back in this project, right, and like I'd want to look at the schematic, I'd look at this and I'd go, what? I can't understand how this works with a schematic like this. This is just, you know, insane. And like, if it was me, I probably would have, if it was in Altium, I would have just gone in there and tidied it up and said, here you go. Then just resubmitted it or whatever, and you know, here's a tidy version, yet nothing. That's what we're stuck with. So yeah, sorry, that is a complete and epic fail, that schematic. Of course, that's not a reflection on the usability of the product, so that's just the schematic, but really that needs to be tidied up. It makes me want to do a video. In fact, I probably have done a video on how to lay out a schematic, but maybe this is a really good example of how this can be tidied up and, you know, to make it usable, because at the moment it's just silly. And as for the PCB, you can see a crazy thing is, like, there's no designators. They've got the values on there. Okay, fine. If you want to put the values on there, that's great. But where are the component designators? There's no point putting 1 meg on there. Like, you can't follow, like, it should be like R9, R10. So before I install the software, I've got to install Python. My machine doesn't have Python, and you can't just install any version of Python. You got to install not the new version 3. You got to install version 2. So this is just ridiculous. I know, fine if you do this every day. I know jack all about Python. Don't have it installed. I just want to run a Windows XE to use my oscilloscope. Is that asking too much? So I'll install Python 2.715 64-bit. It's the latest 2.7 that I can find, or 2.x version that I can find, so we'll give it a go. Now we have to download the software from the GitHub, and it's just clone or download. Like, download zip. And I want you've got to like download the whole lot. Looks like I can't go into I don't know how to use Git. I don't care, like. Okay, let's see if dummy me can, what's HaasoScope draw? Draws waveforms? Okay. Anyway, we've got to, apparently, if you, I think my driver installed correctly, the USB drive, you're supposed to install that there if you haven't done it, but let's see if it, oh, I saw something pop up. Do I have to go to the command line? Probably. Alright, so what am I doing here? I must admit, there is a very comprehensive guide on here, and it basically, yeah, quick start, here it is, tells you to down clone the GitHub and HaasoScope software and then Python draw. So I've got to do that, apparently. Run the software on your computer, use the Python HaasoScope window that pops up. Okay. But yeah, it is actually very comprehensive. Kind of like it. It's got all the pictures and pinouts and all sorts of stuff. Anyway, the screen just pops up as like, I don't know, who is that? So it looks like it can interface with a Raspberry Pi or something, like it's not a direct hat or whatever, but you can do, I don't know, something, troubleshooting guide, all that sort of jazz. So yeah, there's oversampling, serial connection, reset switch, all that sort of stuff. So yeah, very nice comprehensive guide. Thumbs up to that. So I do exactly as per the instructions, Python, HaasoScope, draw, py, and it doesn't work. Look, I know everyone's just going to go, oh, duh, right? I'm obviously doing something dumb, but I follow the instructions, and here it is about halfway down the documentation. Install Python, done that, run this command line script. Here it is. C Python 27 scripts, pip, exe, install, ph serial, numpty, matplotlib, ph side, qt spy, scripty, obviously. Oh! Okay, so let's run that and see if it works. Collecting size stereo. Okay, so it's installing some sort of serial driver doodaddy thingy. Great. This is what I want to do before I run to be impressed with my oscilloscope. Right? My USB. This will change my mind. Still going. But granted, is in the manual. Well, oh, okay. Okay, let's try it now. Apparently the Raspberry Pi thing, the Python application that we're going to run now runs on the Raspberry Pi. So that's what the deal is there. That might be an okay for, like, you know, if you want to do some standalone data loggy, like multi-channel data logger thing, and you control it all with the Raspberry Pi and you hook it up to a HDMI monitor or whatever. That could be useful. Let's see if this thing works. Python is not recognized as an internal command. Well, that's what it said to do. Loading. Here we go. Yay! We're in like Flynn. Check it out. Woot! There you go. It's live updating. Can we go full screen on that? Alright. That's updating what? 5, 6, 8 times a second? Something like that. Okay, it's pretty groovy. If I run my fingers over the back of it. There we go. Got something. Got an impulse. Anything microphonic? No. Oh, gain yet. So I'll turn to super gain, these ones here. Whoa. -3. What? Why is there a 3 volt offset, minus 3 volt offset on super gain? Like, it's only got 2 ranges, and we've got 50 ohm. And why is there a voltage off when I switch to, like, the 1 meg mode? 1 meg mode now. Why is there a half volt offset? 1 volt with super gain. Oh, so 1 meg with super gain gets us close to 0, but not 0. And then we've got like a fixed. How do we, like, can we change? No, we can't click on any of this. Can we click and drag any cursor? No. Oh, okay. Oh, right. Okay. So it looks like we can. Okay. So our right mouse button changes our cursor thing. Got all 4 channels, but I don't like that. That's look. 50 volt, 50 ohm input termination. Nothing connected. -3 volts. Seriously? Like, come on. What is, like, and what options have we got? What's that? It's not horizontal scroll. Oh, this is, oh, no. Oh, that moves our window around. Oh, okay, so we can drag our axes like that. Okay. Oh, gee. No, I want to be able to right-click on that and set my axes. I don't want to. Wow. That's terrible, Muriel. Wow, no. No, we've got zoom. Got some sort of control. Borders. Okay, borders are 0.1. They're like, what, spacing around there? Oh, yeah, right, to go full screen kind of thing. Okay, tight layout. Oh, that's better. Except all the text over here is chopped off. Right? So, reset. There you go. So, it's DC coupled. So, why are we getting that RMS, 11.3 millivolts? What? And close. Where's our waveform updating? X-axis. Oh, my goodness. Look at the decimal places. Oh, if you're a decimal place fanboy. Woot! I've seen enough already to know this is not an oscilloscope, okay? It's a data acquisition learning platform or something. I don't know. There we go. I press home and we're back to -3. Should I even bother putting a waveform into it? Seriously, I mean, you know, time base, microseconds. Where's the microseconds per division? Where's your horizontal time base? Like, you know, well, 2 microseconds per division. There's shortcut keys. Okay. I remember seeing shortcut keys in the manual. Hang on. So here we go. Here's our shortcut keys. Toggle roll-in trigger. So it's like a command line, like hotkey interface. That's just ridiculous. Toggles high-res mode on by default. Click here for details. This is just an 8-bit ADC, by the way. I believe. I didn't even look at the ADC used on it. Toggles 4 times over sampling, 400 meg samples per second. You know, look, you can probably make this thing do stuff, but I just don't see the point in it. It is not, like, I'm supposed to be impressed by this, supposed to change my mind about USB oscilloscopes. Like, there's not a single thing about this that I like as an everyday use oscilloscope. Not a single thing. We can get a log scale axis, linear. I got to go back home to turn on my waveforms. I just look at this. You can execute I2C commands to the I/O encoders. C code. I mean, that's like, you know, hacker's delight, I guess, right? And SPI command to the ADCs. So you can send SPI commands directly to the ADCs. Okay, if you want to script something or do something like that. But, like, seriously, like, and it doesn't even know that we've switched ranges, right? The app thing does not know that we've switched ranges. Like, so how are we supposed to know? Like, we're supposed to, like, manually multiply? Like, I assume it's 1 volt per division on the normal mode. Let me see if I can at least get a sine wave, and then I'm done. Okay, I'm feeding in a 10 megahertz 4 volt peak-to-peak sine wave, and obviously we're getting some alias in there. By the way, if you want to see, it kind of sorta shows up on the screen, but not really. There you go. Like, it's not even coming up as proper, like, full screen or anything. So, like, it doesn't match what's on the screen. So that's like, yeah, I don't know what the deal is there. That's, okay, so I'm feeding in 1 volt RMS now. You can see RMS down here, 0.9 volts RMS. That's with, hang on. Oh, no, there we go. That's with the 50 ohm terminator on. Let's drop that down to 1 meg, shall we? And there we go. There's our 1 megahertz sine wave. How do we set up our trigger? Oh, there we go. Oh, there we go. There we go. It just, is that because I clicked on it? Is that because I clicked on it? Oh, look at that. Okay. There you go. You click inside there and that's your trigger point. That is totally non-obvious, but it does that. It's a bit of jitter there. But there's our 1 meg sample rate. Like, where does it tell us what sample rate it's using? Where, like, how can we change the horizontal time base? I'm pressing some arrow key. Oh, there we go. I'm pressing the right arrow. There we go. And there we go. It's alias in now. Well, yeah, it's really alias now. Whoa. See, what is this offset thing? What is that? Like, all I'm doing is changing the horizontal. Right? That's all I'm doing. Oh, no, there we go. We were seriously aliasing before. There we go. I should have twigged by the time-based setting there. But look, it's just jumping down. I'm not doing anything. I'm just pressing left and right arrows, which changes the horizontal. 1, 2, 4, 8 sequence. Doesn't even have your your traditional 1, 2, 5 sequence. Nah, user interface fail. Sorry. If this is supposed to be an oscilloscope, that is no good. You have to make it look and work like an oscilloscope. And what's that crosstalk we've got on the purple channel, which is channel 3? Oh no, it's always there. Wow, that's a lot of noise on the purple channel, which is channel 3. Got nothing plugged in. And what's the look? The screen's showing some weird ass half waveform thing. I don't. Wow, no, look. Like, what is that? What is that? Nothing. Nah, I'm done. I'm sorry. I'm done. I'm done. Whoa, yeah, check that out. There's something like the same channel, same signal fed into there. I got the same gain on each one. They're all 50 ohm terminated. What on earth is wrong with channel 4? Look at that. Wow. Like, and they're different amplitudes. What the? What? Like, there's something seriously wrong with this. Something seriously wrong. I'm done. I am sorry. I am done on this. Sorry, Andy. Thank you for sending this in, but no. This did not change my mind about USB oscilloscopes, only made it worse. Sorry, please, people, let me know if I'm being too harsh on this. But there's not a single thing I like about this at all. So, well, maybe apart from the, as I said, like cascading together. I don't know how many multiple channels you can put together. I'm not sure about the power distribution between them and, you know, all that. You know, can power one and it syncs across. And maybe as some sort of, as I said, some sort of like educational thing, FPGA Python FPGA educational tool or something. But as a workable oscilloscope, forget it. Sorry. Thumbs down, Andy. So if you like this new, well, it wasn't really shorter because it's like half an hour or whatever, probably. But, you know, only like a couple of items per mailbag. But if I can do it every Monday, let me know by giving it a big thumbs up. And as always, you can discuss down below. Thanks to everyone who sends in mailbag. And yes, I will eventually get to them all. So thank you very much. Catch you next time.